Okay, dear students, so let us see this question. It's a very beautiful question, I would say. Typical IB paper 2 question, which is difficult to imagine but easy to do. So, highly conceptual. Let's see. A space probe of mass 95 kg is designed to land on the surface of the asteroid. The gravitational field strength G on the asteroid surface is given as 2.7 10 per negative 3. The radius r of the asteroid is 230 kilometers. Calculate the mass of the asteroid. Okay, so the acceleration due to gravity is given on the surface of the planet or the asteroid. So whether it is a planet, whether it is an asteroid, doesn't matter, whatever it is, okay? So don't get confused. So we would be using our same formula, which is for the acceleration due to gravity, gm divided by capital R square, where capital R is the radius of the planet of the body. So G dash is equal to gm divided by R square. And accordingly, we can find the mass by creating this formula by rearranging the terms. Now we can just substitute the values. 2.7 10 to the power negative 3. And the radius is given as 230 kilometers. So mind it, kilometer has to be converted into meter because kilometer is not SI square, divided by G value, which is 6.67 10 raised to power negative 11. Okay, so this is the mass of the asteroid. Clear? Because the acceleration due to gravity is given and we can just apply the formula. So I'm not doing it. Let's see what they have done in the mark scheme. Yes, capital M is equal to GR square by G. And here are all the values given here. Exactly the same thing that we did. And after calculating it with the help of the calculator, you would be getting 2.1 10 raised to power 18 kgs. That is the mass of the planet or the asteroid that you are talking about. Now, the next question. The probe is now carried to the asteroid. So the probe is now carried to the asteroid on board a spacecraft. So spacecraft is there and the probe is now on the spacecraft. Spacecraft is moving around the asteroid. Calculate the weight of the probe when close to the surface of the asteroid. So now probe is going to the surface of the planet and you have to find the weight when it lands there. So very easy. So the weight is given as the product of mass and gravity. So I think the mass was 230. No, that wasn't the right thing. We have to find the mass of the probe. That is given as 95 kgs here. Mass of the probe is 95 and the gravity is 2.7 10 per negative 3. So your answer in this case will be, yeah, they have only given the final answer, but this will be 95 kg into 2.7 10 raised to power negative 3. So that will give you the approximate value that will range from 0.25 to 0.26, something you can even round off the value. See, there is a principle of rounding off in IB. Whenever you round off, the answer should be given in two significant figures. That is why you always round it off. Okay, so whatever is the answer, you just round it off and it will be coming within this range. So that's absolutely correct, absolutely easy. Let's go for the next question now. So C1, as the probe approaches the surface of the asteroid, a rocket engine is fired to slow its descent. Explain how the engine changes the speed of the probe. Now, we have to think like the Elon Musk's company, SpaceX. So, this is the probe now. So when the probe is trying to slow itself down, how is it slowing itself down? There are rockets here, those who are firing, and the probe is still straight. It's not bending or something, it is still straight, but it is now moving down, but there is firing from the rocket which is reducing its speed at which it is going down. So it is eventually decreasing its speed and it will become zero when it lands on the surface. So how is this achieved? This is what they want to ask you. So it's just a theoretical question. Explain is the key word. Explain, describe. These words, whenever they're written, it means that you need not to go into mathematical part of it. You just need to write the things. So you would be writing like this is going down, so there is a momentum for the probe. But when the rockets are fired, at that time there is a force which is coming in the upward direction, which is acting in the upward direction, and that is why it is continuously reducing the momentum of the probe, and by the time the probe is reaching the surface of the asteroid, the velocity becomes zero. Something like that you have to write, and let's see what they have written. Okay, so they have given too many alternatives here. No problem. The engine exerts the upward force or the opposing force on the probe. The force is greater than the weight. There is an upward resultant force. This causes deceleration and the reduction in the speed. So there are so many things. You can talk about the momentum. You can talk about these things. Engine causes change in momentum of the fuel molecules. By conservation of momentum, the probe has equal and opposite, like they're now referring to action-reaction pair, by the way. But anyways, you can just create a story here, and this question can be solved. Clear? So now moving next, C3. See, these kind of questions I tell you, the C2, C1 kind of questions, they are theoretical questions, and usually these are the questions where students are not able to get score in paper 2. Why? Because there are different types of ways in which you can answer it, and it could be alternative 1, 2, 3, or you might be creating another alternative by mixing all these alternatives, isn't it? So that depends like what is going on in your mind at that time in the examination hall. So my advice for you is, whenever you find this kind of a theoretical question in paper 2, you have to read the way they are giving the answer. And you have to learn the art of giving answers, like art of adding specifically those keywords which IB is fond of. Like for example, the upward opposing force, or you can say the way they are writing, deceleration, the way they're writing these things, okay? So you have to understand these things, okay? So accordingly, you'd be in a position to write your theoretical answers by yourself without losing any score. Now that is what is the task here, okay? Let's go for C2 now. C2, a constant force of 12 Newton is exerted by the rocket engine. Determine the time for which the rocket must fire to reduce the speed from 0.64 to 0. State your answer in appropriate significant figures. 2 significant figures should be there. So a constant force of 12.0 Newton is exerted by the rocket engine. So this is the probe now, let's say, and this is the rocket here, yeah, and the rocket is shooting. So there is a weight here, okay, and there is an upward force which is 12 Newton, and we just found the weight. What was the weight of this probe? 0.25 Newton, let's say. So we're taking units as Newton, 0.25. So this is 0.25 Newton. So overall, the net force, which is working as inertial force, which is breaking the inertia, or you can say which is giving you the acceleration, F net is 12 minus 0.25. Now this force is equal to the change in momentum by change in time. See, in these kind of cases, you can apply the Stewart equations. You can find like force is there, you divide it by the mass of the probe, and you would be finding the acceleration or the retardation with which it is going down, and accordingly you can apply the Stewart equation. You can do that, but usually this method is better when wait a minute, we have to determine the time. Yeah, so time is there in this equation, so we can just find the time that it will be taking, and the velocities are also given, so we will find the change in momentum. This makes more sense. So it doesn't make sense to go into the Stewart equation. Like students have a tendency to unknowingly or unwillingly, let's say, they invoke the Stewart equation in every other question. So in this case, I'm not doing it. Let's see if there is something else that we can do. So what is the change in momentum? So the final momentum is 0, and the initial momentum was the mass. I think the mass was given as 75 kgs into the velocity, which was 0.64 divided by the time t. I think this equation should be giving the answer. Let us verify the mass of the probe if it is actually 75. No, 95, sorry. Yeah, so this is 95 into 0.64. I think this should be giving you the answer. And let's see what they have done in the mark scheme. So the net force is this. Yeah, they have done the same thing. You see, the net force is 12 minus 0.26. They have taken 0.26. I have taken 0.25. And this is your net force. F is equal to change in momentum. So now they're finding change in momentum, which is 0.64 multiplied by 95. Yes, I am having a negative sign, but you can ignore it later, no problem. So this will be the change in momentum and divided by time. So you just substitute the values and you would be getting the value as 5.2, 5.3. That's it. So this is absolutely correct. This is how we do it. You can go for the Stewart equation. I think this is alternative 1. So probably in the alternate 2, they would be using the Stewart equations. Yes, you can say that because they have found the force, they found the acceleration, and then they are just applying, let's say, v is equal to u plus at, and you can plug in your values and you would be getting the answer. Okay, so this is done. Let's go for the next part now. The question is yet not over. Okay, so this D part now. D part is only for HL students because this is about the escape speed. Escape speed actually incorporates the concept of potential energy, which is not the part of SL syllabus, and that is why escape speed is also not in SL syllabus. So this D part is only for HL. By the way, the same question that we are doing was present in SL question paper also and in HL question paper also, but in HL it had a D part. In SL there was no D part. That was the only difference. Okay, so I have chosen to do the HL question for you, so SL students can ignore the part D. Now show that the escape speed can be given by root of 2gr. This typical IB question, again and again they keep on asking this question. So let us see this again. So overall the escape speed formula is given by 2gm by capital R square root, and this R is the radius of the planet. So you literally talking about the escape speed when the rocket is at the surface of the planet. So R is the radius of the planet. This is the escape speed. The formula I think is given in the data booklet also. This is the escape speed. Now this formula is not given there, okay, but also, even like this is also a very popular formula, I would say, and it is used time and again, but I think this is not given in IB data booklet. Now G value can be written as gm divided by r square at the surface, and so I want to find gm by r square. So what I do here, I multiply both sides within the square root, the numerator and the denominator with r, and so this becomes r square. So we can club it like this: twice of gm divided by r square into r square root, and this gm by r square can be written as g, and there you are, this is root of 2gr. This is what we need to do. It's a very simple derivation, but this is how we do it. So we can say that yes, this is the formula for the escape speed, but we can say that it is equal to root of 2gr also. As such, I would advise you to remember this formula also, 2gr. It's very helpful. Many a times the gravity on the asteroid or the gravity on the planet is given, you can directly input the value and get the answer. So that becomes highly easy. Okay, let's go for the next thing. Calculate the escape speed of the asteroid, as I told you. Okay, so we are just going to substitute the values here. The answer is written as 35. So 2, and I think the gravity was given as 2.7 10 raised to power negative 3 at the surface of the asteroid, and the radius of the asteroid was 230 kilometers, so 230,000 square root. Always remember, we do not work with kilometers. This and this gets cancelled out. 2 into 2.7 into 230 square root. I think this will be giving you the value of 35. We can verify it with the help of calculator. Let me do it. 2 into 2.7 into 230, and absolutely I am getting the answer as 35.2, but we have to reduce it into the two significant figures, so 2 will be dropped, so 35 will be the answer. Always be careful. In IB, your answer should be reported in two significant figures, just as a thumb rule. Okay, now this is D2. Let's go for the question E now. Okay. As the probe lands, okay, now the probe has landed. So this is the probe which you created in your school and you send it to the asteroid. So this probe has now landed on the surface of the asteroid, and there was some stone here. I don't know who put it there. As the probe lands, a small stone resting on the rock on the asteroid surface is projected horizontally. Okay, so we just imagine that there is a stone there, and somebody like this stone is now moving. It is projected horizontally. The horizontal speed of the stone is 34 meter per second, and the height is 1.9 meter above the surface of the asteroid. Estimate the horizontal distance. Okay, so it will be going like this. It becomes the perfect case of horizontal projectile motion, and you literally want to find the range along the line AB at which the stone lands. Ignore the curvature of the asteroid. Yeah, okay, no problem. So we have to just apply this, and if you remember, the formula for the range here is u into root of 2h by g. And the students, those who do not remember it, what we do in this kind of case, first we know the time of the flight, like the time it will take to fall here. So we would be considering only the vertical motion for the shadow, and the time period will come out to be root of 2h by g. So I'm not deriving this formula. You can just apply the SWOT equation here, okay? So the time is given as this, and the range is like, because the body is always moving with the same speed, that is u. So the range will be given as u into root of 2h by g. Okay, that is the range. So because distance is equal to speed into time. So you just plug in the value in this formula and you would be getting the answer. I think we need not to go into further explanation here, but if you need the explanation for this part, this is kinematics, and I have uploaded the lectures for the topic A1 on YouTube channel, which are freely available for all the students to watch. So you just search that playlist. A1 is completely free to watch. So you can go there and you can watch the video in regards to horizontal projectile motion, which is this. So you can learn the basics if there's any problem. So here I'm just applying this formula. So u is 34, height is given as 1.9, and the gravity will be, oh my god, sorry, I have put it as 9.8. That is not right. So it is 2.7 10 raised to power negative 3, isn't it? The height is still 1.9, but the gravity is very low. It's 2.7 10 to the power negative 3. We substitute the value, and when we calculate it, we would be getting the right answer. Let's see. So this is how they have done. The time to reach, like 2h by g, which is 37.5 seconds. The stone is falling very slowly, although it is just 2 meters of the height, but still stone is taking nearly 40 seconds to fall to the surface. You can just imagine what is the gravity there. Distance traveled horizontally, it will be the speed into time. That is 1300 meters. That's it. So it is going like this. So the distance here is 1300 meters. Exactly the same thing that I did. I have just written the formula root of 2h by g. So you can just use this formula and you can plug in these values. Okay, dear students, so this is how we do this question. This is the end of this part. So this question is very popular, and it is in it was asked in HL, it was asked in SL, and it's a very popular question. Many students have asked this question to me. Okay, dear students, thanks for watching. Keep watching the videos. All the best. Bye.